Hi everyone, my name is Sharon Ferguson, and today I will be presenting our study, Why Couldn't We Do This More Often? Exploring the feasibility of virtual and distributed work in product design engineering. This work was done with James Chen, Safa Fayadi, Kimberly Lai, Kevin Leonardo, and Dr. Alison Oliowski from the Ready Lab at University of Toronto, and is currently under review at a journal. So COVID-19 forced a lot of employees to work from home, but it did not impact all industries equally. In Canada, 40% of employees were working from home in March of 2020, but 30% of manufacturing workers still worked entirely in person, with another 24% working from home less than 10% of the time. In the US, 44% of employees worked from home in March, and 78% of manufacturing workers surveyed said that at least portions of their jobs still required in-person work. We chose to present this study today as the continued virtual work that we're likely to see post-pandemic will have consequences for almost all areas of design theory and methods research. For example, existing team science trends such as shared mental models and information sharing may need to be revisited in light of working from home. The COVID-19 pandemic has forced design teams to adapt and take on ill-defined problems, where shared mental models are even more important, but harder to accurately build. This also highlights the importance of research surrounding collaboration methods that can continue digitally, such as collaborative CAD. Communication patterns change when working virtually. Spontaneous conversations happen less often, more communication takes place via text, and many teams choose audio-only calls. So how do these changes impact our understanding of engineering communication patterns? Are miscommunications more or less frequent? With less access to physical prototyping parts and facilities, the roles of physical prototypes may change. Even as some designers begin prototyping from home, it will still be harder to communicate design ideas and decisions when these prototypes are shown over video instead of in person. Will the purpose of physical prototypes change? And will teams prototype more or less often? With some or all team members working from home, some design processes will need to be adapted, like the physical redlining process, for example. Teams will need to rethink how they organize information and how they make decisions. We can also ask, are certain design methods less effective when working virtually, and are some even impossible? Will the physical flow of the phases in the design process need to be altered to best make use of limited in-person time? In terms of ideation and conceptual design, although some authors suggest that virtual brainstorming will actually result in more and higher quality design ideas, the process of conceptual design may need to change in the presence of hybrid teams and having more time to brainstorm individually. Are there certain ideation methods that are more effective in this scenario? To answer these questions, we first need to understand the primary challenges that product design engineers are experiencing in this working style, and what strategies are organically emerging to mitigate them. So our study looks at virtual work, which in itself has been well studied, but never before has it been so widespread and unplanned. We focus specifically on product design engineers who work with hardware products, where there has been the long-standing assumption that their work cannot be done virtually. We asked the question, what challenges are these engineers experiencing when working virtually, and how are they currently addressing them? If product design engineers can move towards a more flexible work schedule, allowing them to take advantage of the many benefits of working from home, we can create a more adaptive and diverse workforce. To go over a little background, while global product design teams are growing in popularity, it is rare to see entirely virtual and dispersed design teams in industry, and there are many reasons for this. Researchers believe that physical distance decreases communication frequency, which is important for knowledge transfer and innovation in engineering design. Access to any physical parts for prototyping or testing is limited when working from home, and these are essential to the engineering design process. Creativity is another important concept in engineering, and whether virtual workers are more or less creative is still to be determined. While working virtually allows for more time to brainstorm individually and provides the opportunity to share ideas anonymously, both of which may increase creativity, other research has shown that the combination of the environment, the designer's personality type, and thinking style all impact design novelty, so not all product design engineers will be impacted equally. Because the product design process includes distinct tasks, many researchers have used task technology fit theories to understand what tools to use when, and we can use this framework to understand challenges by phase of the product design process. We conducted 20 interviews over 2 months in order to capitalize on the COVID-19 imposed work-from-home situation. We interviewed 7 women and 13 men spanning 16 companies and 10 industries, including nuclear, automotive, and medical. Participants were recruited through our professional networks and through the Alumni Association at the University of Toronto. And we chose our participants based on those who worked closely with physical products in their daily job in positions like engineering designers, physical product designers, and mechanical engineers. Our interview spanned 6 categories, and we asked our participants to identify which phase of the Ulrich and Eppinger generic product design process that they had been working in most during the work-from-home period. We asked about the most challenging part of virtual product design work and if their team had devised any strategies to overcome these challenges thus far. We also inquired about their attitude towards virtual work and their team dynamics. We began the analysis by separating descriptions of challenges from the descriptions of the tools and strategies used to address them. Because many of our participants worked in more than one design phase throughout the virtual work period, we worked to reach consensus and classify each instance into a single design phase, or into a few general categories if it was not phase specific. Repeated analysis allowed us to tease out the underlying themes experienced by multiple participants. The first clear theme was that our participants and their organizations previously believed that it was not possible to work in a virtual and distributed manner, as evidenced by these quotes here. It was a once-in-a-blue-moon kind of thing that people would work from home. Because we are such a hardware-focused company, we had generally discouraged working from home. One of the co-founders really equated number of hours in the office to how hard people were working. So I'll start by briefly describing the reoccurring challenges that our participants brought up, organized by phase of the product design process. In the planning phase, participants described a lack of transparency when coordinating projects, and they struggled to see their teammates' progress. They also found building rapport to be difficult, as evidenced by this quote here. If you've never met someone before, it's harder to get people to understand that you're not just the name sending emails to them. They're less likely to respond or less likely to attend your meeting. In the concept development phase, they found brainstorming to be restricted and the virtual whiteboard tools that they were using were ineffective. In the system-level design phase, they found that they required more effort to reach alignment between all parties needed to make system-level decisions, and that there was a lack of accountability for these decisions. In the detailed design phase, they found CAD access was slow, they lacked access to physical benchmarking tools, and they received less feedback on their designs. In the testing and refinement phase, they lacked access to testing and prototyping facilities, and they found that there were fewer opportunities to de-risk the product before sign-off, as fewer members got to physically review each prototype, as described in this quote here. Normally in the office, we have somebody in charge of checking colors of printing and colors of product. Because I don't necessarily have that experience or knowledge on how to evaluate it, I miss those type of things. Lastly, in the production ramp-up phase, they were challenged by the inefficient transfer of information between production teams, and there was less supervision of production activities overall because there was a limited number of staff on site. Although our participants found virtual work to be challenging, they were already devising strategies to address these challenges even within the short first few months of virtual work. In the planning phase, they introduced weekly check-ins and utilized project tracking tools that provided visibility into project status. In the concept development phase, they used virtual tools to rapidly represent concepts as they would use a whiteboard in person, such as by screen sharing an iPad. In the system-level design phase, they moved to model-based approaches so that the ground truth of their design was a model that everybody had access to. In the detailed design phase, teams adopted lightweight software tools for reviewing and sharing CAD designs, as shown in this quote here. We used Onshape for CAD, and they have a follow command. We can double-click that person's icon at the top, and your screen will follow their mouse and all the motions that they're doing. So that's how we would do a lot of the sharing and communicating. In the testing and refinement phase, they used digital reviews and sign-offs. They sent detailed testing reports from the testing staff to the design staff, and they began to rapidly prototype from their homes. In the production ramp-up phase, they utilized continuous video streams of production lines for when design staff could not be present at the manufacturing facility, as shown in this quote here. We were able to set up a bunch of really good camera setups around the lines. We were able to have multiple Zoom calls basically going on. We'd have a couple different rooms. One might be focusing on assembly issues and one might be focusing on calibration issues. We're interested in seeing their hands and the tools that they're using. So we all know that communication becomes increasingly difficult when working entirely virtually. And we also know that communication underpins most activities in all phases of the product design process. So we heard a lot about communication in our interviews. and we decided to separate communication challenges and strategies into their own category, spanning all phases of the product design process. Participants found knowledge transfer to be a lot more formal when done over email or messaging, and they experienced a lack of visibility into the problem solving and innovation in other teams, as shown in this quote here. There is a miss of the random conversations, just finding out that, oh, you're dealing with that problem, we had that problem 3 years ago. Let me send you an important report on that. The serendipitous interactions dropped down. They found that the lack of nonverbal communication online made it more challenging to gauge understanding and agreement in their teammates. And they found that virtual work introduced some accessibility barriers that were not always top of mind, as shown in this quote here. Accessibility features like captions on meetings can be really helpful to people who are either deaf or if they're speaking English as a second language. Having a caption is going to be really helpful, and that's not always available to everyone. While our participants had yet to find concrete solutions for many of these challenges, they did share that by creating explicit opportunities for water cooler conversations, helped to share information, strategies, and tools between teams that would not normally meet in their day-to-day, such as functional teams. Towards the end of the interview, we asked participants how they felt about virtual work moving forward, and it was clear that almost all participants were excited about some type of hybrid approach in the future. Spoken directly by our participants, I can totally see it being divided by, I've got these 3 meetings, I'm going to come in on Wednesday and have these 3 meetings. And then for the rest of the week, I'm doing my CAD work, in which I don't really need to interact with somebody. I think that will continue into the future because there's no reason not to. And we absolutely have to have access to a test lab. I need certain machines and equipment to be able to do my job as a mechanical engineer. So I don't think that we'll ever be able to move entirely to a remote work model, but I do think that we can probably scale down at some point. As with most things, there's no one solution that will make virtual work productive and enjoyable for all product design teams. We heard many unexpected positives from our interviews and contradictory results depending on the team. Some reported that virtual meetings allowed more employees to participate, it increased flexibility overall, and it allowed for team discussions to be more inclusive, which resulted in decisions being made in a more decentralized and democratized manner. But other participants reported feeling that these meetings had less engagement and that they were overwhelmed by the number of meetings on their calendar. Overwhelming staff with meetings has been shown to cause stress, fatigue, and increased perceived workload among employees. Another aspect for design teams to consider when planning the switch to virtual work is the concept of a critical mass, which was echoed by multiple participants in the study. Setting up the infrastructure and processes for virtual and distributed collaboration will only be worth the effort if a sufficient percentage of the team adopts the practice. Managers should also be wary of overwhelming their employees with meetings and tools. Although we have a breadth of tools available for us now to help us communicate and plan, having too many tools can be a time sink. It can cause confusion, and it can increase employees' perceived workload. There are also still challenges that need to be addressed. For example, we heard from multiple employees that the one thing they missed the most about in-person work was the whiteboard, and that the current virtual options just don't compare. Follow-up studies to this work could revisit product design engineers post-pandemic. Which challenges that we listed here still persist? And what percentage of the time do product design engineers continue to work from home? And does this correlate with job satisfaction or product success? In conclusion, we found that virtual product design engineering is feasible, and each phase comes with its own distinct challenges and promising solutions. Some tasks are more productive virtually, while others might always require at least a few workers on site. Challenges include coordinating complex projects, brainstorming virtually, receiving design feedback, and conducting physical tests. And strategies include topic-focused meetings, model-based systems, lightweight CAD sharing tools, and video testing. Lastly, we believe that moving forward, a more flexible work model can lead to more adaptive and diverse teams, which in turn will develop more innovative products. So thank you so much for listening. Please feel free to contact myself or Dr. Olejowski if you have any questions regarding this work, and you can visit the ReadyLab website to see more of our projects. Please feel free to pause the video here if you'd like to explore the work that I've referenced in more detail.